Let's talk about the curl of a vector field. Alright? Now, when you let water out of a sink like a wash tub or a face basin or a kitchen sink, you usually see it will form a whirlpool. Alright? It is pooling around, swirling. In the case of hurricane, right, you have air that is swirling around in a circle, right? It's rotating in a circular pattern. Now, the thing is, you can represent that swirling by vectors like this. It's clockwise or like this if it is anti-clockwise. Now the anti-clockwise movement in this case is considered to be positive curl. And the clockwise is negative curl. Alright? Now, you have these things occurring in various situations, as I said before. You're letting out water from a sink. You have sometimes you have the wind blowing. You can see some type of circulation of air carrying dust and tree leaves, right, swirling around. Or if you're mixing your drink or mixing your tea, you swirl the spoon around. Alright? So in that case, the liquid has a curl. Now, if the water that you let out of the sink was going like this, straight towards the drain, or if you have some spray that's spraying a lawn and the water is spraying straight out like this, these would be zero curl. You must have rotation in order to have a curl. Alright? Now, the curl, this is what you say is the curl. Alright? It is the cross product of nabla and the vector. Nabla, again, is equal to the partial by partial x in the I direction plus partial by partial y in the j direction plus partial by partial z in the k direction. And A is a vector. It's ax in the I direction plus ay in the j direction plus az in the k direction. Ax, ay, az are functions of x, y, and z. Right? Now, here, nabla, again, it is waiting on something to act on, and it will act on A. But now, remember what the cross product is. The cross product of two vectors here, you could write it as a 3 by 3 matrix. You have the directions I, J, and K. So you have I, J, and K. They will be here in row 1 of the matrix. So row 1 contains directions, the I, J, and K. Alright? Now, row 2 will contain the coefficient of I, J, and K that are on the left. Right? So it will have what is in the X direction here, what is in the Y direction here, and what is in the Z direction here. Right? So row 2 contains coefficients of the directions of the left vector. The left vector would be the nabla. And then row 3 now. Row 3, let me just write it first. Row 3 contains coefficients of the directions let me rewrite that. Directions of the right vector. So remember, the directions are the I, J, and K. I in the X direction, J in the Y direction, K is the Z direction. So row 2 contains whatever multiply I, J, and K on the left in the left vector. Row 3 contains whatever multiply I, J, and K in the right vector. The right vector, those things are AX, AY, and AZ. Now that is the determinant that will give you the curl of the vector. So here, earlier we saw that gradient or grad acts on a scalar to give a vector. Divergence or div acts on a vector to give a scalar. But curl acts on a vector to give another vector. This. Now, you have to remember how you find the determinant of this vector. Now we expand along the top row. So the curl, that is the cross product between del and A, is equal to I and this determinant, because you cover up the rows and column that contains I, is going to be delta by delta Y of AZ minus delta by delta Z of AX. Alright? Then minus, remember the place signs, minus J times, you're going to cover the rows and column with J, and you're going to get, there should be a delta here, the determinant with these ignored. So in fact, let me write it in determinant form first. So let me not skip over that. You are expected to remember how to deal with it. So it's going to be delta by delta Y delta by delta z, ay, az, alright, it's going to be this determinant minus j. You cover the rows and column with j, so you're going to have delta by delta x, delta by delta z, ax, az, alright, plus k by this determinant here. You're going to cover the rows and column with k, so you're finding this determinant here. So it's going to be delta by delta x, delta by delta y, ax, ay. So here now, we run out of scrolling space, you know. But anyway, del cross A is going to be I times delta by delta y of az minus delta by delta z of ay minus j times delta by delta x of az minus delta by delta z of ax plus k times it's going to be delta by delta x of ay minus delta by delta y of ax. Right? But we can't scroll down anymore. Run out of scrolling space. Alright, so here, of course, it's best remembered as the 3 by 3 determinant. Right? So that's the formula calculating the curl. So the curl now, see what I had before. Nice. So we're saying that positive curl is in the anti-clockwise direction, negative curl is in the clockwise direction. If there's no rotation, there's no curl. Right? And the curl is really del cross A, or nabla cross A. Because it's upside down triangle, they call it either del or nabla. Alright? So the curl work on a vector to give you another vector. Alright, so I'll see you in the next video.